Hello and welcome to my channel. I am Mensah Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we'll be looking at how to evaluate limits graphically, and we will graph this piecewise function and look at some examples under it. So we use this piecewise function to draw a graph, and then we use it to evaluate some limits under the graph. Now, here it is very simple. If we take x or values of x less than -1, f of x is equal to 1 divided by x squared. So let's assume these values: -2, -3, and -4. So if this one we have f of -2, that will give us 1 out of 4, that's 0.25, and 0.25, let's approximate it to once again to 1 decimal place, that is 0.3. We take f of -3, that will give us 1 out of 9, that is 0.1. If we take f of -4, give us 1 out of 16, and that will be 0.0625, so that is 0.1. So let's take that way. Now, for x greater than or equal to -1 but less than 1, we have a straight line equal to 2. For x greater than 1 but less than or equal to 2, we have a straight line that is 3. But for x greater than 2, we have our f of x to be -1 on x minus 2 all squared. So we use your calculator to check this. Now let's take these values greater than 2. Let's take 3, 4, and 5. We have f of x. If we put here 3 minus 2 is 1. 1 squared is 1. -1 divided by 1 is -1. That is if we put 3 inside. If we take 4 minus 2 is 2. 2 squared is 4. -1 divided by 4 will give us -0.25. That will give us -0.3 to 1 decimal place. If we take f of 5 minus 2 is 3. 3 squared is 9. -1 divided by 9 will give us -0.1 to 1 decimal place. So check all those for me to see. 1 divided by 5 minus 3 squared. 5 minus 2 squared rather. Yes, that will give me this. And okay, so what we've done there is correct. So we are going to plot this set of values. For this one, we'll be plotting -2, 0.3, -3, 0.1, -4, 0.1. We've approximated this. And this one too, we are going to plot 3, -1, 4, -0.3, and 5, -0.1. So let's see. Let's draw the graph. I want the graph to be this, because you don't have negative values for f of x. So let's take here to be negative. Oh yeah, we are having, where? We are having this. Okay, so we have to redraw the graph well. If it comes here, it's okay. So we have 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. We have here to be -1, -2. minus 1, minus 2, minus 3, minus 4, minus 5. Okay, so let's plot the values. Now, here, oh, this one is. Here you are having 2, so negative 1 to 1. So you trace this one to the top. Negative 1 is included, so you shade it. But 1 is not included, so you do open circle. Okay. Then, yes, for 3, we have 1 to 2. 2 is included. So we have 1. 1 is not included. But 2 is included. Wow. Okay. Now, let's look at this one. We are going to have, we took values less than x, which means x is not included. Sorry, which means negative, we took values less than negative 1, which means negative 1 is not included. But if we take f of negative 1, then when we get 1 on negative 1 squared, and that will give us 1. So we can plot that point and it is not included. So we show it with a circle. And that point is not included. Yes, we show it with a circle. That point is not included. Okay. So we look at negative 2. Take, let's put the 0 here. And let's say that this is 0.5. I want 0.3. So 0.1, 0.2, 0.3, 0.4. So 0.3 will be here for 2. And then 0.1 will be here. And the same thing will be here for 4. So let's draw the graph. Wow. So this is y equal to 1 on x squared. Okay. Now it has left with this one. You plot 3 and 1. You are plotting 3 and 1. 3 and 1. We are plotting 4 and negative. Oh, we are plotting 3 and negative 1. 3 and negative 1. We are plotting 4 and negative 0.3. So 0.1, 0.2, 0.3. Then we are plotting 5 and 0.1. And we are saying that x is greater than 0. Sorry, x is greater than 2. But let's see something here. Let's put in 2 there to see that if the endpoint can be a whole. If we take negative 1 on 2 minus 2 squared, we are getting 1 on 0, which is undefined. So it means that we cannot put a whole here. It is undefined, we cannot put a whole there. So it will be an asymptote. So let's draw. To go this way. In my curve, let me do it well. Yes, let me do it well. This one is more than what I did earlier. Okay, so here, if we take 2 minus 2, it will be 1 divided by 0, which is undefined. So this is why it will go. So this one is y equals -1 divided by x minus 2 all squared. So let's use it to answer these questions and then we'll go our way. First, we have to answer this question. We have to take the limit as x approaches -1 from the right of f of x, and the limit as x approaches -1 from the left of f of x, and then you take the limit as x approaches -1 of f of x and see. Now, where is -1? There's a -1. So as x approaches right of -1, let's trace it and see. It will get to 2. And this is line y equal to 2. And this one is line y equal to 3, as we have indicated. So here, this one will be 2. And as x approaches -1, that is f of x. So as x approaches -1 from the left, we are going to use this one. The limit as x approaches -1 from left, 1 on x squared. And if we trace it, we are getting to where? 1. If we trace it, we are getting to 1. Very simple as that. So in fact, this one will be the same as the limit as x approaches -1 from the right of 2. And we have this. So you see that the right hand side limit and the left hand side limit. So the limit of f of x as x approaches -1 does not exist. So this one does not exist. Wow, very simple as that. Because as x approaches -1 from the left, we use this function. And it's going to this point. But from the right, you come to this and it is 2. Let's take the next one. The sub question under this one. Okay, so we will take the limit as x approaches +1 from the right, and then the limit of f of x as x approaches +1 from the left. So let's see. From the right of +1, this is +1. This is +1. So from the right of +1, this is coming because we trace this to that. So this one is coming. So we take this to be equal to the limit of 3 as x approaches 1 from the right, and it's a 3. But from the left, this one is coming. So it is the limit of 2 as x approaches +1 from the left, and that is 2. So we see that the limit of f of x as x approaches +1 does not exist, since the left-sided limit and the right-sided limit are not the same. Because this one, for the right-sided limit, you use y equal to 3, and for the left-sided limit, you use y equal to 2. So they are not the same. Let's look at this. We are almost done. And then you look at the limit of f of x as x approaches 3. Now, as x approaches 3, and where is the 3? As x approaches -3 rather. And where is the -3? This is -3. And you see that the left hand side limit and the right hand side limit are defined by the same function. So here, the limit as x approaches 3 from the right of f of x is equal to the limit of f of x as x approaches negative 3 from the left. And that is equal to the limit of 1 on x squared as x approaches negative 3. So it is the same function. And here, as x approaches negative 3, what do you notice? You see that the value will approach this dot. And that dot is what? Positive 0.1. So this is positive 0.1. So this is 0.1. So the limit as x approaches negative 3, 1 divided by x squared is positive 0.1. For both the left hand limit and the right hand limit are defined by the same function. So that is what we have there. Let's take the next one. The next one is the limit of f of x as x approaches positive 5. Now let's go to positive 5. As x approaches this from the right, it is getting to this dot. From the left too, it's getting to this dot. And it is the same function that is used to define the right hand side limit and the left hand side limit. So this is the same as the limit as x approaches 5 from the left of f of x is equal to the limit of f of x as x approaches 5 from the right. And that is the same as the limit as x approaches 5, negative 1 divided by x minus 2 all squared. And that is what? This point. If we trace it here, we said it is negative 0.1. So it is equal to negative 0.1. Very simple as that. It is being defined by the same curve. That's the same curve that we have here. Very simple as that. And the last one is the limit of f of x as x approaches 3 out of 2. Is the same as the limit of f of x as x approaches 1.5. 3 divided by 2 is 1.5. So let's locate 1.5 on the number line. It will be somewhere here and it will fall within this. So it is the same line that is being defining the left hand limit and the right hand limit. So the limit of f of x as x approaches 3 divided by 2 from the right is equal to the limit of f of x as x approaches 3 divided by 2 from the left, which is the same as the limit of f of x, the limit of 3 as x approaches 3 on 2. And that is what? 3. Because as we approach half, that is 1.5 here, we will move to 3, both from the left and from the right. Thank you for watching and please subscribe to my channel. Bye bye.